Okay, so good morning once more and welcome back. So we want to begin by looking at network troubleshooting overview. So we want to have an overview of network troubleshooting. These particular topics set precedence to the next coming topics, which I'm going to give you as a reading assignment. So here we're just going to have an overview. But the next two topics, I expect you to read them. They are very interesting topics on how to systematically troubleshoot the different parts of your network. Now, to most modernized enterprises, the stable running of a network infrastructure is of great importance. So service interruption due to network faults may lead to output loss, profit loss, and damage the reputation of the company. So therefore, network troubleshooting is indispensable in the plan, design, implement, operate, improve model. So we are going to see exactly where it fits. So by the end of this chapter, you should be able to, Owen.
Objectives. By the end of, upon completion of this section, you will be able to master a structured network troubleshooting process,
Yes.
master network troubleshooting methods based on paths that service traffic passes through.
Passes through, exactly. Thank you. So let's begin by looking at the PDIOI and network troubleshooting. So what is a network fault? What is a network fault? Now, a network fault is any symptom that affect the services of a network. Any symptom that affects the services of a network. So when a specific network function fails due to certain reasons and services are affected, then a network fault occurs. So any symptom really that affects the services of a network and the normal operation of a network is referred to as a network fault. Now, we are going to look at some of these symptoms here. So generally, this has been divided into types and symptoms. Now, network faults can be divided into hardware fault, configuration fault, network fault, performance fault, software, interconnection, and other faults. So those are like the categories. Now, each one of them will result in a number of symptoms, one or more, most likely. So some of the symptoms include an alarm. So is the fault going to cause an alarm? So for example, a hardware fault most likely will cause an alarm. Performance fault, for example, if the CPU is at 100% usage, most likely it's going to cause an alarm. Then the other symptom is when you're having loops in your network. So for example, if you do misconfiguration of OSPF areas, for example, or STP, then you might have loops in your network. Then service failure, things that will cause the service to fail. Service interruption. What is the difference between service failure and service interruption? So service interruption is temporary and most of the time slows the service. So something like that. Packet loss, protocol exemption, when you're having errors in protocols due to configuration or misconfiguration, protocol flapping, when it's keep on changing, paths are recalculated and so on and so forth, and also route exemption when we have a problem with the service paths that we have created using maybe traffic policies and so on and so forth. So generally, those are some of the network types, network fault types, and some of the symptoms that you might encounter from each one of them, which has been checked there. Now, on the PDIOI, network troubleshooting also falls under the operate stage. So under operate, we have routine maintenance and also troubleshooting. So let's look at structured network troubleshooting process. Sorry. Okay. So if a network troubleshooting is performed based on personal intuitions and past experiences, it may cause the following problems. Just a moment. Okay, apologies for that interruption. Okay, so generally, if you don't follow a structured network troubleshooting, then you might have certain problems such as difficulties in team collaboration because no one knows what you did to solve the problem. Most likely you've not documented it because you're just doing it from personal intuitions and your past experiences on how such problems are solved. So really you don't have a summary document for that. And also this might not help us to troubleshoot further on later stages, for example. So those are some of the problems with solving or doing network troubleshooting on personal intuitions or past experiences. Now, this particular flowchart shows us the structured network troubleshooting process. Remember, this particular structured network troubleshooting process is triggered by a fault report. So most likely, we've had a problem that has been reported in our network. So that is where we start. So really, it provides a rational method for locating, first of all, the cause of the problem, then for rectifying that particular fault. So really, you begin by verifying the fault, that is confirming that indeed there is a problem. Then you collect some information about that particular problem. Then you identify and analyze the fault. So we're going to look at some of this. Then you come up with a possible list of causes for that particular fault. Then you evaluate the troubleshooting complexity. Is it a very big problem? Is it something that is within your scope or not? Then you check the causes one by one. So you came up with a cause list and you're going to filter it and also check the causes one by one. Then check whether the fault is rectified or recovers. So if this happens, then you simply rectify the fault. If no, then you'll have to go back to collect more information about that particular service. After you've rectified the fault, you might need to perform ending works, like doing the proper documentation for what you did and suggestions, for example, for future maintenance in order to avert such problems in the future. So that is what we call the structured network troubleshooting process. Now, with non-structured network troubleshooting, look at this. So here you've verified a user has reported, for example, that they are unable to access the internet. So you verified that indeed they're not able to access the internet. You've collected some information. For example, at what time did this start, blah, blah, blah. We're going to see some of the details that are usually picked. And after collecting the information, you begin, you immediately begin trying to solve that particular problem through several ways. So you don't identify and analyze fault, you don't do an output cost list, you don't evaluate, you don't check the causes one by one. No, you just keep, after collecting the information, you go directly here and you try to solve the problem. So that is what you call non-structured network troubleshooting process. So you're simply analyzing the fault based on your intuitions and past experiences. Okay. You see, you also don't perform any ending works with non-structured network troubleshooting process. You won't. Simply solve and move on. Okay, so now reporting a fault. So this is a case scenario. On Monday morning, you receive a call from an employee reporting a fault. So the fault is, I cannot access the internet on my PC. Please rectify the fault as soon as possible. So what should you do after receiving this call? What should you do after receiving this call? So as we've seen here from the structured network troubleshooting steps, the first thing we need to do is after the fault has been reported, we need to verify. We need to verify the fault. So let's look at this. How is that done? So you need to verify the fault through proactive communication. Proactive communication. So that is, query the user about the preceding information over the phone and record it in the troubleshooting report. Now, some of the details that you might need to collect, for example, is the fault reporter. So details you need to collect is the name of that person, the department, the job position and level. Very important. Now, for example, a user has reported that, hey, I'm not able to access the finance server, for example. But from their job position and level, you might be able to know whether they are allowed in the first place to access that server or not. So that's why you need to collect such information, the responsible field, the PC location, including the room, floor, and whether they're using wireless or wired access, etc. So other than that, you might also need to find out the website that they accessed when that particular fault occurred. Okay, let me just mute one of you. I think it's here. Okay. Okay, then you might also need to collect information about the fault frequency. So whether the fault is unexpected, occasional, or frequent. So you need to find out that, is it a common fault, or is it occurring for the very first time, for example. Then user operation. So user operation on the terminal before and after the fault occurs. So what did you do? What did you do? Is there anything you changed? Is there new software you installed, for example? And did you change the firewall and security system settings, for example? So any user operation that they might have performed just before the fault occurred. So you also need to find out about that. Okay, so on reporting a fault, speculating the cause. So we have a question here. Why should I obtain the job position and level and responsible field of the user? So I think I already explained that, for example, users of different job levels may have different network access rights. So also users of the same job level may only have the rights to access network services that are related to their jobs. So why do we do fault verification? So fault description of a user may be unclear at times, and the failure point reported by the user may be mistaken. So we have an example here. A user calls you, they tell you, hey, I'm not able to access the finance server. And I think the server is down. I think the server is down. While in the real essence, it's not the server that is down. Maybe it's their cable. Maybe it's actually the switch or the interconnection between the switch and the server. So really, yes, they have reported the server is down, but the server is okay. So you need to understand as a network engineer that the fault description, you should always expect this, the fault description of a user most of the time is going to be unclear. And the failure points that they report may be mistaken. So that's why we need to do fault verification. Okay. So how do we then do fault verification? Most of the time we use these 4 key elements in fault verification. So number 1, we look at the entity. We look at the entity. Now when you talk of the entity, we mean which network service has failed. Which network service has failed. Then number 2, we look at the symptom. The symptom is what is the symptom for that particular fault. Then look at the time. When did it occur? And then the location. Which network component has failed? So entity is the service. So for example, email service, DNS service, web service. Symptom is, for example, the network is too slow, or I'm unable to access my printer completely. Then the time it happened, location is which part of the network then might have failed. So you need to provide an accurate description of the symptom and also determine whether the fault is within your scope of responsibility. So do you have the corresponding rights to rectify this particular fault? If no, then you need to hand it over to the other team. Now, when collecting the information, we have several collection methods. We have several collection methods and collection tools. For example, you can use CLIs. So for example, the command prompt. The command prompt. For example, to do a ping or a trace route. So you might be able to use such like things. You might also need to use, for example, packet capturing tools. So packet capturing tools such as, what did we call it? What we've been using. What do we call that packet capturing tool that we've been using for the labs? Why am I forgetting the name?
Wireshark.
Exactly, Wireshark. You might also need to use Wireshark, but actually you can collect information from your NMS, like eSite. So those are some of the collection methods. You also need to attain authorization. So for networks with strict information security requirements, you have to be authorized. And most of the time, this authorization should be an official document signed and maybe sent over email, or you have the physical document. Other than doing authorization requirement, you also need to assess the risk that is involved with this particular process. For example, sometimes when you're doing when you're collecting information through the CLI, like through the command prompt, or even through the VRP eSite, and you use certain commands such as debug OSPF. So such commands might also result in high CPU usage. So you see, when it results into high CPU usage, then it might also slow down other network services. So you need to assess the risks for information collection, and therefore be able to balance this particular risk and also the risk of creating a new fault. Okay. So identifying and analyzing information. So here we need to, first of all, find the information about the fault, any information about previous maintenances that were done, any changes that was done either by the user or the team, and also you need to learn about the team experiences about similar faults. So by doing that, then you're able to identify and analyze the fault, and the results of identifying and analyzing the fault is coming up with a cause list. So all the possible causes for the problem that is being experienced, for that particular fault that is being experienced at the moment. So the cause list will have several. The cause list will have several causes. For example, the first list will have around 6, for example. Now you need to do information filtering. By doing an elimination filtering, we mean you eliminate the least possible causes. So excluded causes, they go into that list. You eliminate them. Then the most possible causes now remain on the cause list. So that is how we do analysis of the problem. You also need to evaluate the troubleshooting complexity. So, of course, from the output cause list, you need to evaluate the troubleshooting complexity. Is it within your scope? So evaluate troubleshooting complexity before checking the causes now, one by one from the cause list. So is it within your scope? Is this something that you can be able to solve? So if not, then you need to refer it. You need to refer it to the team that can handle it. If yes, then you can go ahead and check the causes one by one, and maybe now come up with the root cause, identify the root cause for the problem. So you really filter it further in order to identify the specific problem that has caused the fault. Oh, okay. I think I had mentioned this some time back. Sometimes you might need to build a temporary environment. The temporary environment, when you're troubleshooting, is an environment which can help users to continue working as you sort out the problem. So, for example, the CEO accesses the network and internet services, maybe through a wireless access point, and you've identified a problem with that particular hardware. So you might swap that access point with a non-working one as you try and find out the real problem with that particular access point, because you need them to continue accessing the network and internet services. So sometimes that is what we call building a temporary environment, so that the user can continue working and the network services are accessible. So how do we then do this? Checking causes one by one. Okay, so here, really, you need to balance the urgency for solving an existing fault against the risk of causing a new fault. Sometimes you try to solve a problem and you create many others. So that's why you need an emergency plan, and you also need a rollback preparation. So you need to notify the user of the risks of this troubleshooting and perform any operation only after the user has permitted you to go ahead. So they need to be aware. So after that, you can now go ahead and look at the causes and come up with a root cause for that particular problem. Now, rectifying the fault. So after you've identified the root cause, you need to rectify the fault. Something important here. So in some cases, you need to observe network services for a certain period also after the fault has been rectified. So you need to continue monitoring that particular network. So how to rectify the network, the fault is you need to observe the network services continually and also perform ending works. You need to perform the ending works in terms of any documentation about the problem and also any recommendations for future maintenance and upgrade. So this is what we're talking about when you're talking of performing ending works. So ending works, they're very important. So here we're just insisting that they're very important. And ending works will include documentation handover and also notifying the user. So documentation handover, for example, the process documents for troubleshooting, what you use to be able to allocate that root problem, the summary reports for troubleshooting, like how long you took and such like things, and any change, backup, or maintenance suggestions. So those are some of the documentations that you might need to hand over. Information notification, so all impacted parties need to be notified, most of the time through email or SMS. Authorized parties in all phases also need to be notified, and also any vendors and service providers that were involved in that particular troubleshooting need to be notified. So really, we've gone through this. We've gone through this flowchart up to performing ending works, and really, as you can see, compared with an unstructured network troubleshooting process, actually the result of a structured network troubleshooting process are very predictable. They are very predictable, and troubleshooting really is well controlled, and also the risk of causing any new faults is minimized, is greatly minimized, because really we are following a well-structured procedure in solving the problem. Okay, so let's look at some of the core theories and common methods of network troubleshooting. So really, the TCP/IP model forms the basis of network troubleshooting theories. So we are going to see two theories, bottom up, top down, and really all of them are in reference of this particular layered model of communication. So the physical and data link layers in the open system interconnection reference model also require attention. So really, whether you're doing so by using the OSI reference model or the TCP/IP model, just one and the same thing. The thing is, they offer the basis for network troubleshooting theories. Now, troubleshooting theories are based also on service traffic paths. So as we know, networks are designed in such a way that they offer certain services. For example, they offer finance services, they offer office automation services, production services, or any other services that the company is running. Therefore, we can create traffic paths based on these services, Uh, and therefore, to troubleshoot the network, we can be able to check the data flow direction of any particular service. And normally we do this either using the ping command or using the TRASAT tool to test whether the current paths are consistent with how we designed them in the first place. So you can also troubleshoot networks based on the service traffic paths. So this is how, for example, we confirm service traffic paths at the network layer. So you're simply checking routing paths of packets at the network layer. So here, for example, you simply do a TRASAT just to find out if you're able to reach this server either through this direction, this path, or through this path. So you have two paths, and you can be able to use the TRASAT, for example, to find out whether, for example, if you had specified this particular path for accessing this server, then you'll be able to confirm whether it's working correctly. So that is what we do. So you can also confirm service traffic paths at the data link layer. So again, at the data link layer, we want to check the forwarding paths of data frames on switches at the network interface. So here we check the MAC address on the table switches to find out whether the MAC address of a particular device is there. We also sometimes also check the port roles of the port roles of STP to find out which ports have been blocked. So for example, here we can access this server either through this path, or we can access it through this path. So maybe in our initial design, we've blocked that particular interface. And so we don't expect this path then, path 2 here, we don't expect it to exist. So we can check and verify the path. And therefore, if that path, for example, is available, then we know maybe something is not working correctly. So that's how you do that. Again, with this, you might also use packet capturing tools such as Wireshark to find out. So these are the two methods. We can either do top-down fault or troubleshooting. So here, with top-down, most of the time we do top-down if no fault is detected at the network layer connectivity. If no fault is detected at the network layer. That means, for example, we are able to ping. We are able to ping the destination. But we still have other problems. So we need to perform top-down. We check problems from the application layer. For example, is the firewall blocking traffic, or is there any other changes that are restricting this user from accessing that site? For example, some websites, if the date of your PC is wrongly set, they cannot allow you to access their website. So if you're able to ping Google, but the user is unable to access Google, so you see, it's only reasonable for you to be able to start from the application layer, looking at things like the date, the firewall, and so on and so forth. So that is one example of that. On the other hand, the bottom-up approach is used when a fault is detected at the network layer. So you do a ping and you're not able to ping Google. So when that happens, please use the bottom-up. Use the bottom-up. So begin from the physical layer. Check things like, is the network cable really connected? Or if you're using Wi-Fi, is the Wi-Fi connected? You got the data link layer. Are you able to access other devices? Are you able to access other devices at this particular layer? So you can actually also swap with another device. Is a different device able to access through this particular cable, for example? So anytime there's a problem at the network layer, then you need to begin or use the bottom-up method. So it's important that you know those two ways of troubleshooting. Okay, so sometimes, for example, as you troubleshoot, you might need to compare configurations. So for example, you use the command display SAS1 brief just to find out whether the settings, the configurations are actually working normally as provided in the documentation. So this particular kind of troubleshooting is normally used with personnel who have limited experiences, just to compare the configuration and see whether there's a difference somewhere. So that's one of the things that you can do to those are some of the things that you can do to troubleshoot and find out whether you have issues, for example, at the network layer. So you can, for example, compare even the IP address of two interconnected interfaces. You can display interfaces brief to find out on R1 and R2 to find out if the IP addresses are on the same network. For example, if you're not able to access them. So some of these techniques are well explained in the coming topics, which I've given you as a reading assignment. The other technique you can use other than comparing in troubleshooting, you can also replace entities with a non-good, non-good working entity. So, for example, some of the things that you can replace, for example, is the cable. You feel like maybe there's a problem with the cable, so you can swap it with a non-good working cable. Or you think maybe the user's PC might be having a problem with configuration or antivirus or a virus and so on and so forth. So you might also replace. So simply connect a laptop, for example, on this cable and see. When you connect the laptop, are you able to access whatever you want? You can also replace the networking devices, like the switches and routers. So really, this is one of the ways of troubleshooting. Method is commonly or frequently used in hardware troubleshooting. So in software troubleshooting, most of the time we use comparison. We use this one. We compare configurations, for example. But in hardware, most of the time we swap with non-good and working entities. Okay. So what do we have here? Part by part troubleshooting. So you can analyze the configuration files of the network devices part by part. So this is, for example, when you want to compare the configurations. So you can begin from the management part. So when you talk of the management part, we're talking of the router name, the password, the service, the logs, etc., etc. Are they okay? Are they okay as expected? The interface part, you check the IP address, the encapsulation, the duplex mode, the cost, the authentication, etc. So after doing that, you can also go to routing protocol. So on the protocol, you can also check a number of protocol configuration and whether they are working correctly. Then on the policy part, you can check the routing policies, PBR, any security configurations to find out if they're okay. Then at the access part, you're checking whether you can be able, for example, to telnet or SSH connect remotely to that particular device. And other applications part, you're checking, for example, the quality of service configurations and if it's being implemented correctly. So that is what we call the part by part troubleshooting, where you are moving from management to interface, routing protocols, etc. The other one is segment. Okay, let me say this, that with part by part troubleshooting, you do this when a network fault is located on a specific network device. So you need to do this by analyzing the configuration files of this device in order to further narrow down the fault scope. So you do part by part of that particular device. Now we have segment by segment troubleshooting. Segment by segment troubleshooting. This is normally used when locating a fault on a large-scale network. So we want to see really or identify where the problem, the exact location where the problem is occurring at. So again, this is done in order to narrow down the fault scope. And most of the time, we do segment by segment troubleshooting when we want to confirm the traffic paths of the affected services. So like this one is a very complex network. Now we can be able to test from this PC, are we able to access the internet? So we can be able to use the ping, the TRASAT to find out the path that is being followed. And if we have a failure at any point, then we will be able to know, for example, using the TRASAT, if a failure occurs at this point, for example, we will be able to know that, hey, your packet is not passing this particular point. And so this is what we call segment. Really, segment by segment, we are troubleshooting from the access layer, then we go to the aggregation layer, and then to the core layer. So that is what we call segment by segment troubleshooting. So ladies and gentlemen, that is the end. That is the end of this particular chapter. So please find time and go through this question in order to understand it. Anyone with a question? Okay, asanteni sana.